Hello students, welcome. Myself Princy Evangeline, handling physics for grade 12 at Vailankanni Senior Secondary School. We are going to see the second experiment, which is to find the resistivity of a wire using meter bridge. So the aim of this experiment is to find the resistance of the given wire using meter bridge. So we are going to see the apparatus required for this experiment. This is meter bridge. We need meter bridge for this experiment. Then we are having battery eliminator, which is the electricity source for the experiment. And this is known resistance box. This is jockey to connect it with the meter bridge. This is one-way key. This is unknown resistance. And this is the galvanometer. So these are the apparatus that we need to find the experiment. So this is the circuit diagram for the resistivity of the meter bridge. First, from the A side of the meter bridge, the battery is connected. Then the battery is connected to the key and it is again connected to the B of the meter bridge. And another side of the meter bridge is connected to the galvanometer and it is directly connected to the other side of the meter bridge. Here we are having two gaps in the meter bridge. In one gap we are attaching resistance box and in the other gap we are attaching the unknown resistance. So this is the circuit connection for the meter bridge. Now let's see how to give connection to the meter bridge circuit. First we are having battery eliminator. The positive of the battery eliminator is connected to the A of the meter bridge and the negative is connected to the key and the other side of the key is connected to the C of the meter bridge. So we are having galvanometer connected to the center of the meter bridge and the another negative of the galvanometer is connected to a jockey. We are having two gaps in the meter bridge. First gap is connected to the unknown resistance of the wire and the another gap is connected to the known resistance box. This is the circuit of the meter bridge. We have seen the connection circuit. Now we are going to see how to take reading for the meter bridge. First we have to place the key and then we have to take the jockey and we have to place the jockey at the ends of the meter bridge. We can see the deflection at the last edge and if we keep the jockey on this opposite direction, we can see the deflection in this side. So we can see that the connection is working. First we have to take the reading. For that we have to take the jockey from the A side of the meter bridge and we have to move it till the last side to see the reflections. We have seen the deflection showing in the galvanometer if we place it at the edges. Now we have to move the jockey along the meter bridge and we have to see where it is showing null deflection. So here we have seen the null deflection. So we have to note the reading here 45. So this is the value for the 1 ohm of the meter bridge. Now we have to change the ohm to 2 and do the same procedure. We have to change the jockey from this side. Full deflection is showing. So we have to gradually drag it from this side until the deflection is null. So here it is having 0. So we have to note the value 33, which is the value for the galvanometer. Then we have to change the ohm to 3 ohms and we have to repeat the same process. We can take reading for 5 ohms and we have to calculate all the values and take the mean, which is the final result of this meter bridge value. The working theory of the formula of the resistance X is equal to 100 minus L divided by L into R. 100 minus L. Here the L is the length that the null deflection that I have shown in the reading divided by L, the same length of the reading, into R. R is the resistance ohm that we have said. So this is the formula which is we are applying in the tabular column. First resistance ohm 1, 2, 3 which we are changing in the order. Next we are having length. Length is the length that we have seen the null deflection in the meter bridge. Next we are having length 100 minus L. 100 is the whole range. So we have to subtract the length that we have taken with 100. So this is the third column. Fourth we are having resistance. The same formula that I have explained here we have to apply here. Divided by 100 is 100 minus L this. Divided by this into R. R is this. So this is how the resistance came. Finally we are having the mean value. Mean value is the total summation of this value. So this is the mean value. The final result of the experiment is the mean value that we have taken here, which is 2 ohms. So this is the result of this meter bridge. We have seen how to take the reading. Now we are going to see the tabulation. First in the tabulation we are having resistance, length DC, resistance and mean. First resistance. Resistance is the ohm value that we have taken like 1, 2, 3, 4, 5 which we are keep on changing. that is entered here. Then we are having the length L centimeter. That is the centimeter which are showing null deflection in the meter bridge. Then we are having length DC 100 minus L. The length which have been subtracted from 100 is calculated here. Then the final resistance formula X is equal to 100 minus L divided by L into R. We are having 100 minus L value 66 divided by L value 34, which is equal to the resistance value multiplied by the resistance. So we have to find the mean for all the resistance and we have to find the mean value, which is the final result of the meter bridge. Here we are having 2 ohms. So 2 ohm is the mean average value result of meter bridge. Hope you guys understand this experiment. The main point that we have to keep in mind while doing this experiment is that once you started moving the jockey from one side to another side, it is not important that which direction it is moving. It is very important the movement should be very gradually slow and the null deflection should be perfect so that we can take the correct reading. So this is the thing we have to keep in mind. Hope you understand this experiment. We can see the next experiment in the next video. Thank you.